This is Unit 10, Organic Chemistry. Lesson 4, Isomers. How are isomers identified? The objectives of this lesson: I can identify isomers of alkanes, alkenes, and alkynes, and I can construct isomers of alkanes, alkenes, and alkynes. Do now. So isomers are defined as compounds with the same molecular formula but rearranged in a different structure with different properties. An example of an alkane: this is butane, C4H10, and notice that I have 4 carbons in a row here. This is 2-methylpropane, where the molecular formula is C4H10. So I have the same molecular formula but 2 different structures. Therefore, I have different properties. So check and see, match the isomers, and check your work. These 2 have the same molecular formulas but different structures, and these 3 all have the same molecular formula but different structures, and therefore different properties. Drawing an isomer, you will use the same molecular formula but arrange the atoms in a different structural arrangement. So both of these have the molecular formula C5H10. However, the double bond, if you notice, is in a different location, therefore it's a different compound. So for example, draw an isomer of hexane. So you can do these in your notes. So first you need the molecular formula. This has 1, 2, 3, 4, 5, 6 carbons, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 hydrogens. So I need to have over here 6 carbons, 1, 2, 3, 4, 5, 6, and 14 carbons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is 2-methylpentane, which has the same molecular formula, C6H14, as hexane. But because it's in a different structure, it's a different formula. So here is that 2-methylpentane written out clear. Here are 2 isomers of butene. When I have a double bond, I can easily just move that double bond. So when I have isomers of alkenes or alkynes, the double or triple bond, just put it in a different location. So just be careful to not to move it into the same position, because remember, you can read compounds left to right or right to left. So sometimes if you just switch the side, you end up drawing the same thing. So for example, draw an isomer of 1-pentane. So here the double bond is on the end. So what I can do is draw my 5 carbons and just put the double bond on the second carbon instead of the first. So check your understanding. And now you can identify isomers of alkanes, alkenes, and alkynes, and you can construct isomers of alkanes, alkenes, and alkynes.